Hello, welcome to the Machine Learning Engineering course. So my name is Matthew Daw. I'm based in Provo, Utah. I studied at Brigham Young University for my undergraduate degree. I'm also there for my graduate degree right now. For my undergraduate, I studied applied computational mathematics. That's kind of more the background or level of math behind machine learning and modern data science. I also worked for AFRL, Air Force Research Laboratory, and there I researched computer vision models. I was able to publish a paper and did improve the state of the art in computer vision detection. Then after that, I went to work at Ben Labs. At Ben Labs, I worked at engineering, ML ops, DevOps, about back engineering, and kind of everything that goes around machine learning modeling. And so, the biggest reason I think why machine learning engineering is taking off is because of the research. As of 2017, we really started to see really strong exponential growth, and the number of papers that are being published. Nowadays, we're getting around 4,000 papers published per month. So lots and lots of research and lots of excitement about this. And all this excitement, of course, means lots of potential for product market fit and ways to monetize it. So back in 2011, there was about $2.1 billion being invested into machine learning, but now it's getting towards $83 billion. There's been a lot of success, we continue to see more success, and the growth hasn't stopped. All right, so when it comes to machine learning engineering, there's roughly three categories of topics that you can talk about. One is more data engineering, which is preparing a data set, making sure you have good pipelines to collect it, store it, clean it, and test it, all that. And then another category is development and training. So when it comes to development, you're actually making the machine learning model. You have to get into the math, build deep learning models, train it, and then once the model is built, you have to train it, do a bunch of experiments, figure out the exact right parameters that are right for your business case, make sure it's trained off the data, figure out what architecture is best, all that. And then another big aspect is just writing the code itself, making sure you can version it well, use Git to deploy it, create CI/CD testing. And then another big part of machine learning engineering is, of course, the deployments, where you have a model, you have it tested, awesome. Well, now you have to deploy it to AWS or some other tool, put it in an API, maybe do some batch inference training, and make sure that you can scale up to fulfill your customer's demand, or scale down and save cost. Also, you gotta make sure you're monitoring it, make sure it doesn't break, and continues to work as expected. And so, so kind of the big areas for machine learning are reinforcement learning. That's mostly doing with robotics. So it also does a lot with game optimization. Another one is computer vision, as far as figuring out what is the type of image, what objects there are, where they're going, what classes they are, what have you. There's natural language processing, where you take large amounts of text and try to gain insights about the text. You ask questions, summarize it, continue dialogue for what comes next, all that stuff. Then there's social networking, where you take large graph data sets and figure out how to partition it, figure out what communities are there, what communities are interested in what, how they group, how communities form, all that. Another one is financial modeling, where I try to predict, hey, I have this money, how should I invest it? What's a good economic policy for my government, or just how to spend money wisely, I guess you could say. And so, there's more stuff I could add to this list, but the point is that at the end of the day, what machine learning does is it gives the ability for computers to be able to find insights by themselves and give companies the ability to know that they're data-driven. It validates their ideas. It makes their products interactive, so that way they can adapt to the specific user, and it makes it possible for products to be able to be exactly fitted to whatever circumstances the user wants, be able to gain really deep insights that humans can't really gain by themselves, or at least require an enormous amount of work to gain. And a lot of excitement around this. I'm really excited to be able to teach this to you, and that's the intro. Thank you.